Hey, this is Dr. B, and let's take a look at some early evidence for the atom. Let's take a look at the work of Antoine Lavoisier. He asked himself if atoms combine to form a new substance without any loss of mass. And for that, he came up with an experiment where he trapped everything in a chemical reaction, including the gases, and not surprisingly, he found that mass was conserved. And so for him, let's remember him by his instrument, which was a double pan balance, which is one of the first instruments to show up in the scientific arena. John Dalton also was interested in atoms, and he asked himself whether they had the same size and masses. To do that, imagine a reaction between magnesium and sulfur to make magnesium sulfide. If atoms have the same mass, then 1 gram of this should combine with 1 gram of that to make 2 grams of magnesium sulfide. If you used a little bit too much magnesium, you'd have some gray residue remaining. If you had too much sulfur, you'd have some yellow residue remaining. Just the right amounts, and you get only the white solid. What he found, not necessarily in this exact experiment, but what he found was if you reacted 24 grams of magnesium, it would react with 32 grams of sulfur. And in accordance with what Lavoisier found, it would make 56 grams of magnesium sulfide. So what he found was that, shown here, atoms do combine in small whole numbers, and in this case 1 to 1, and are not necessarily of the same mass. And in fact, different elements always have different masses and different sizes. Let's use the symbol of an earring to represent Dalton because he's talking about atoms combining in small whole numbers, and that combining we now understand as a chemical bond, which we can symbolize by this hook here. This is early evidence for the atom.